All right, here we are. We are live with a weekly recap. And man, this is a tall order, Rob. We have had an entire week of content here in week 2 of 3 at reInvent. And it is our job to try and summarize all of that in about an hour. So I don't know how you're feeling about this, but there is so much to talk about.
Definitely a challenge, especially considering that this week the two keynotes have both gone deep on their respective topics of machine learning and infrastructure.
Yeah, exactly. Again, a year of firsts, especially here at reInvent 2020, and with that, we have the first ever machine learning dedicated keynote. Out of the pair of us, I know I'm always the one that loves to geek out on all the machine learning launches, and this one certainly just didn't disappoint. And we'll talk about all of those launches in just a minute, but the launches in the ML space at reInvent here did not start this week. They started in Andy's keynote last week, and we covered that in the Andy Jassy keynote recap. We covered that in the weekly recap last week. So I'll try my best to stick to the ones that Swami covered in his keynote in particular here. But then, more recently today, we saw the infrastructure keynote from Peter DeSantis. Always a very unique recap, in that it sort of sheds light on a lot of the work that AWS does under the hood to deliver on some of those foundational products and services. But again, as someone who works at AWS, a lot of that is even news to me. So it's one of my favorite keynotes in the entire lineup.
Yeah, Peter's infrastructure keynote is usually a talk or a pretty well viewed talk at prior reInvents. So this year was no exception. But before we dive into the details, Nick, I want to give the viewers a quick kind of a viewer guide for how to get the most value out of these recaps. As Nick mentioned, there's so many launches that even we have trouble keeping track of them, and we work here. So we know that it's a lot of information flying at you at a constant speed. And really what we're trying to do is to help you detect that one topic or that one keyword that you're interested in. Maybe you're at a certain phase in your machine learning journey, and what you really want to do is look for ways to reduce model drift in your ML pipeline, or maybe you're wondering whether or not a particular database can run on ARM. Our hope is that kind of as we go through these keynotes and announcements and feature launches and service launches in rapid fashion, you're going to find something that resonates with the way that you use AWS. And then you're going to go to the reInvent session catalog, and you're going to type in those keywords and find the session that takes you deep into that. And of course, the keynotes themselves are also available on demand, so you can watch those whenever you want. And we highly recommend that you do watch those whenever you want. But again, the point of this is to really serve as a recap. This one is the weekly recap, so it's a little bit longer. But still, we don't want or intend for this session to be the only way that you consume it, reInvent by any means.
Yeah, precisely. We're simply trying to surface some of this exciting information, give you the bird's eye view of some of the new exciting launches, so that you, like me in some prior years, I may discover that a launch happened, weeks or months down the line that you could have been using or I could have been using at the time. That's certainly not a good feeling, right? If it's live now, it's in preview or it's generally available. We want to make sure that you don't miss that in the trough of launches that certainly happen. It, again, can be tough to keep track. We just want to make sure we get everything in front of you so that you're not missing out on some of the goodies that other people are very excited about. And that we are as well. And hopefully you'll get to see that as we geek out on a lot of these really exciting service and feature launches. But without further ado, Rob, you mind if I kick things off with the machine learning keynote?
Be my guest.
All right. I have to fight the urge to break out into song in the Be Our Guest song. Anyway, sorry, it's been a long week. So we saw at the start of the week the machine learning keynote from Swami, VP of machine learning here at AWS. There were a handful of sort of broad sweeping philosophies for how we at AWS see the machine learning and AI space. If you've been a machine learning AI user on AWS for a while, a lot of these approaches and methodologies may seem somewhat familiar. But again, first time being or first time having an ML keynote, to many folks, this is the first time they're being exposed to a lot of this. So I'll try my best to recap that very quickly. This takes the form of the 3-tier AI and ML stack. If I had to break down the core philosophy of AI and ML at AWS, it is to put machine learning in the hands of every developer. And the reality that motto has to grapple with is that machine learning takes place in many different forms in the hands of many very different people at given organizations, right? So you will have everyone from folks that are trying to get down and dirty with fundamental EC2 instances with the latest and greatest GPUs for optimal processing, that and people that want to run their own proprietary or custom frameworks or forks of them, all the way up to the top tier where folks may want a fully managed solution where they don't want to train anything themselves. They want to be able to use a fully managed AI service out of the box to do things like computer vision or text to speech, for example. And we have a whole slew of features and services for everybody in the middle, namely Amazon SageMaker. If you've heard anything with relevance to machine learning on AWS, this is probably what you've heard. It is a fully featured platform that enables developers to be able to abstract away a lot of the infrastructure and really focus on what matters most, which is training and deploying their machine learning models without all of the hairy bits of what has to happen under the hood for that to be possible. Point algorithms at your training data, get the model output, deploy those, assess the results, so on and so forth. And we will touch on a lot of the launches here in this keynote that make that process a lot more fleshed out, that a lot of customers that have been using it already have been asking for. So that is, the that's AI and ML on AWS in a nutshell. And hopefully when you see some of these launches that we'll talk about, that'll make a bit more sense. But before we talk about any of the launches, there was this one phrase that Swami used a lot. There've been a lot of phrases here throughout reInvent. So Rob, I'm going to ask you to help me out here. What was the phrase that Swami used?
Yeah, I believe he said freedom to invent. And I almost consider this an elaboration of the principles of reinvent, or what was Andy's 8 points? I think it was like a culture of reinvention, right? I see these as kind of running parallel to those kinds of 8 points and principles for reinvention.
Yeah, certainly so. And we're not going to get there. There were only a few here, so we don't have to talk about all 8. We covered that last week in the Andy Jassy keynote recap. But a few of them here and the tie-ins to the relevant service launches. So first is providing firm foundations. Again, this is going to be the bottom layer of the stack. A lot of these higher order managed services like SageMaker and its standalone AI services are built on this strong, performant, cost-effective bedrock. This includes EC2 instances. This includes deep learning AMIs. This includes optimized frameworks that have fully identical and compatible bindings for TensorFlow, PyTorch, what have you. Now, with respect to some of the exciting launches here, going even more foundational than what folks may think. Again, launching inferential last year, we saw the announcement for AWS Trainium, a custom AWS Silicon chip for extremely high or the most, as it claims, cost-effective training in the cloud. It's not quite available publicly yet, but if you're interested, I would definitely reach out on that preview page so that you can get exposed to them as quickly as possible. Again, inference in the long scale or the long term at scale will be the greater cost, but training certainly something that could be cost prohibitive to a lot of customers. Next up, we had the announcement for faster distributed training on Amazon SageMaker. I think there needs to be no introduction as to why something happening faster or cheaper is valuable, but I'll try to contextualize it as much as possible. With Amazon SageMaker, you prepare your data, you have it available typically in some sort of static data store like S3. It could also be in a database, but most commonly a training data set is prepared as a static artifact. And then what happens is you use SageMaker's SDK to point one of these managed training algorithms, essentially, at your training data source. And SageMaker under the hood will, using whatever configuration you provide, spin up and provision all of the infrastructure, deploy your distributed training job to this cluster of instances. It manage all of the iterations of that training, and then once completed or errored, will tear down all of that infrastructure for you. And that all happens with one line of code. Now, the beauty of that is that it makes it very easy to be able to perform what is a lot of complex functionality. But a lot of that is now abstracted from you. Now, this launch is essentially saying, okay, hey, here at AWS, we have gone and we have further optimized the way that your model framework and your data is parallelized across that cluster, and you can see performance gains of up to 40%. Again, this is one of my favorite types of launches because it happens quietly and under the hood without customers having to change any of their code. But when you are billed for the clock time on these training jobs, essentially what this means is you can either, for the same budget, perform your training much faster, or if you want to run for more epochs, you'll likely be able to get higher accuracy for the same amount of money. So again, broadly applicable launch that puts more money in people's pockets at the end of the day.
Yeah, that's a good call out. The ability to speed up certain parts of SageMaker and make it run more smoothly is always a welcome change, and it just kind of makes the whole value proposition of the end-to-end pipeline that SageMaker helps you manage and run and reason about and secure. It just makes that whole proposition even stronger than it was, right? And we already see a lot of customers successfully using SageMaker to make some seriously dramatic improvements in their day-to-day workflow. We heard stories from Lyft where they had models that used to take weeks to train. That's been reduced to days. We have Vanguard, who was able to leverage SageMaker and speed up their deployments by a factor of 20. And then we have companies like the NFL, where we had Jennifer Langston, an SVP at the NFL, who was able to share some insights in how they use computer vision on SageMaker to better understand player collisions on the field and how they were able to use that data to then improve the rate at which players use the safest available equipment and to understand safer tackling and playing techniques. So you can see that from these customer cases, we see companies across all sorts of different industries, all sorts of different sizes and shapes, using machine learning in a deeply integrated way, in a very mature way. And a lot of that is enabled by SageMaker.
Certainly so. And, again, to truly deliver on putting machine learning in the hands of everybody, this it will have to take multiple forms because every organization's needs and wants are going to be very different. But one thing that is a constant is that if you are to choose the route of building end-to-end pipelines, there's a lot of what we like to call undifferentiated heavy lifting along the way. Now, if I had to bifurcate sort of the machine learning journey for an enterprise or a startup, any team that's looking to get their feet wet with training their own models, there's really two big phases. The first is going to be creating your first end-to-end pipeline for the first time, going 0 to 1. And then the second phase, while there may be a scale from 1 to few, which may look a little different from few to infinity, like once you have truly deployed an end-to-end pipeline that is somewhat more than a naive implementation, a lot of the juices start flowing where you begin to realize, oh, hey, well, once I may have another iteration of this model, or I may want to have multiple models in production at the same time, how am I going to handle this part of my pipeline or that part of my pipeline? Or how can I do this in a performant or efficient way? And so, whereas in prior years, the launches of SageMaker 2 years ago, then SageMaker Studio, a sort of all-encompassing hub and IDE by which SageMaker can power it under the hood and have tie-ins and allow someone to really have a control center for all the data that for the experiments they're running. Now, sort of, we see this full end-to-end process fleshed out, and for people that are organizations that are AI first, I would say, or are truly some of the pioneers here. They've had to implement solutions for some of these parts of the pipeline. And, we saw these launched in Andy's keynote, but we'll call them out again. The need for a feature store, for example. Again, machine learning is powered in the training side by data, but you're serving inferences in real time oftentimes. And you want to be able to pull those features, which are the X variables that then create the inference, which is Y. And there's some considerations around latency. You oftentimes want this to be extremely performant. So we've seen use of in-memory databases by customers in the past. But there's a very particular pointed sort of access pattern here for using data storage with low latency for one to multiple models. And so the launch of SageMaker Feature Store helps to simplify that drastically. Again, everyone knows what they want their feature store to look like and the shape of it and the performance characteristics, but no one's business is to run a feature store. It's to serve requests to their customers. So excited to see that. A bit further upstream on the data processing side, Of course, there's a large number of data processing services here at AWS, but when we're talking about data processing challenges for machine learning, there are some unique access patterns, right? We very often will find, the need to standardize data such that it can fit into an algorithm without having that algorithm sort of keel over or throw an error, right? Things like having a category or a feature have mixed data types like strings and nums. Data Wrangler says, hey, these are the common gotchas or the pitfalls in someone trying to prepare a data set to ingest into a machine learning algorithm. And Data Wrangler, just like its name implies, empowers you to very quickly, transform that data. Again, with a keen eye on what that will need to look like to feed into a machine learning algorithm. Um, Going downstream a little bit here, and I know I'm just firing these off one by one, but we have so much to cover this week. We actually have Amazon SageMaker Clarify. Now, there is a concept in machine learning called model or data drift. This is by which, when you create a model, you make an assumption about that data set. And you say, okay, this data set, based on what I will try to perform predictions on, should be indicative or is fundamentally indicative of and representative of the sample that I will be then performing inferences on. Now, that's a lot of technical jargon, especially for folks that may not be knee deep in this type of stuff. But a really common example I like to give here is, if we all go outside, we look on the street, we can see things that we all call cars. Now, there's two common scenarios where model or data drift may come into play. One case would be if you go to a drastically different part of the world. What look like cars there could be drastically different than what we identify or have in our data set. Now, we as humans can reason about things and understand that, yes, those are also cars as well. But a machine learning model without those represented in their data set would not be able to actually assess that. And the problem here is that those inferences could be served and silently failing or giving bad predictions. So SageMaker Clarify helps to identify this and grant a little bit of observability into our machine learning pipelines. We also see this happening over time, right? Cars change even in a given geography. And so we want to be able to detect if that drift is happening so that we have our up-to-date models. A really cool open source component to this, the actual algorithm behind how it does drift detection was open source. I'm really actually surprised they didn't mention this in the keynote. There's SageMaker Clarify is a fully managed service for it, but some of the most novel components there is is sort of the logic behind that drift detection. So really cool and excited to see that being open sourced. Next up, we have deep profiling for SageMaker Debugger. So once you have your models out in production, maybe you have one, maybe you have many. We always talk about right sizing our instances. We want to understand whether our infrastructure is being right sized for the applications that are operating on it. Right. We don't want a bunch of cores on our GPU to be sitting there latent. Right. We don't want a bunch of expensive accelerators not being used because of some other bottleneck in our pipeline. And like I said before, the machine learning infrastructure is hairy. There's a lot of bits that come into play here that you don't really want to have to handle, but you do also want the peace of mind or the ability to have that introspection where possible. So SageMaker Debugger, generally available today, enables you to have this deep introspection into the GPU, CPU, and IO usage of your neural network training, such that you can spend only what you need to spend. Right? You don't want to be wasting money on expensive, on relatively pricey GPU instances in the training phase. And again, if you're taking machine learning seriously, this will add up to a lot of money and cost savings from what you can optimize over the long run. And then lastly, and then
Yeah.
I'll take a breath.
Oh,
Sorry, last one before I breathe is the bow and the ribbon on top that ties it all together, and that is Amazon SageMaker pipelines. So I've been talking about pipelines this entire time, right? Like there's just this standard entity, and in many ways, it is right. It's the value chain in which you derive value from your machine learning work. You don't really get value until all of it works, from data ingestion to cleaning to model training, model selection or algorithm selection, model selection, deployment, and then finally serving instances or serving requests right through that deployment. SageMaker Pipeline says, okay, well, this is an atomic unit. We talk about microservices all the time. Your machine learning service should be just like this, from training to deployment to management. And so pipelines is this meta entity. It's a managed service that gives you CI/CD for the entirety of your end-to-end machine learning stack. So all of those other SageMaker feature launches that I just talked about are constituent parts of a SageMaker pipeline. So We didn't have to wait for pipelines. They came along with a lot of these other quality of life services. So I'm going to drink some water now because I just flew through all of those ML launches in like 4 minutes. But I know that there are some more that are not, that don't have the word SageMaker in them.
Yeah, I just wanted to uh, add on that the deep profiling feature, um, this one is really interesting because sure, when you say it out loud, like, oh yeah, deep profiling for neural network training, why wouldn't we want something like that? Why wouldn't we want to visualize GPU, CPU, and IO usage? And the thing, there's two subtle things I want to make point out here. One is that not all training workloads are the same, right? And by being able to visualize the utilization of these different resources, you can then have the data to tell you what instance type you need. Like you mentioned earlier, attaching a bunch of GPUs to your machine is expensive, but just to what extent is the balance of GPU and CPU optimal for your particular use case? And with profiling, you get to know that, right? The other thing that we're going to tie this into later is the extreme importance of managing your end-to-end energy usage, carbon footprint. At AWS, this is a global problem for us at the scale that we operate at, right? But I think the response, this is also another example of a shared responsibility, because at the end of the day, you want to be able to make sure that you're doing the work that actually needs to be done. And we'll talk more about this in the infrastructure section. But if you believe that this is a problem that's worth solving, like we do, you can't actually start solving that problem until you have the tools to measure it. You have the tools to tell you whether your hypothesis is on the right track. And so you really, like, deep profiling is a step in that direction. I hope to see this kind of thing make its way throughout the rest of the SageMaker pipeline in the coming months.
Yeah, one more thing I'll add on there is that users of machine learning frameworks. We saw the stat in Swami's keynote, but some very large amount, I believe it was 90+% use more than one framework. And so when we're talking about having deep introspection into this isn't just about having observability and telemetry on the underlying infrastructure. You need to deeply understand the framework and how you perform that telemetry and measurement within that framework. And the unfortunate reality is that a lot of those frameworks have very different ways in which you would monitor them. So in a world in which we have developers using a large number of these frameworks, or at least more than one, you don't want to have to relearn how to do this, have this observability multiple times. And especially if you are exploring new options, if you accept the reality that there are likely to be new machine learning frameworks that will be prevalent that do not exist today or are not popular today. By having SageMaker Debugger, this is essentially an abstraction on top all of these frameworks, again, many of which are optimized to be even more performant than their open source equivalents here on AWS. So if you're in machine learning for the long haul here, SageMaker Debugger is really the one-stop shop for trying to understand how to use your infrastructure efficiently and get the most out of it. But I lied before. There's actually one more SageMaker launch, and that is SageMaker Edge Manager. So when we're talking about edge devices, think IoT devices, think the need to have hyper low latency or to perform inference and server requests directly where that data may be getting captured, like at a camera or a physical like earthquake detector or like a seismic sensor, right? There are a lot of unique challenges here, from power to intermittent internet connectivity to lower CPU or GPU processing power. And so SageMaker Edge Manager tries to abstract a lot of the difficulties of packaging and building and deploying these to the edge. Again, an expansion of SageMaker Neo, which is some of our frameworks to help perform some of those lower level packaging. SageMaker Edge Manager makes it easier to manage the deployment to fleets. And so you get all of that, all the niceties that you would with other types of infrastructure. But
Nick, you're still a liar, because there's one other SageMaker announcement that I think we should tip our hat to, which is SageMaker Jumpstart. And you wanna take this over and tell the viewer what Jumpstart's all about?
yeah, exactly. So, I talked on and on before about machine learning. You don't get the value until you have the end-to-end pipeline in production. And now, you can go and build each part of those, each component in that pipeline. SageMaker Pipelines makes it easier to deploy these en masse over and over in a repeatable manner. And lots of these features that we've launched here are those nice to use components. But what better way than to be able to stand up an end-to-end pipeline very quickly to either experiment on and modify very easily, or to be able to simply mock up and have other parts of your organization that can work at the data layer, that can work on the training layer, or work on the deploy the side that will consume those inferences, right? And that's exactly what SageMaker Jumpstart does. It quite literally gives you a jumpstart into standing up an end-to-end machine learning pipeline with a number of very common use cases, right? So regardless of what type of image you may be trying to detect a certain object within, the end-to-end implementation of an image processing pipeline with the labeled training data set that goes into an algorithm and does all of those things actually is fairly standard, at least in terms of popularity and prevalence of these implementations. So we have taken a set of very common reference algorithms and data set types, and we've built these end-to-end solutions that are available to spin up with one click directly in SageMaker Studio. So again, your one-stop shop, the SageMaker Studio IDE, and I would really implore you, if you're serious about this, to look there first. Don't try to write code from the ground up for your first machine learning model. Be able to take a look at this, and oftentimes you'd be surprised how easy it is to simply change the data source for the S3 get call, and how much of that infrastructure can largely encode can stay constant and have you actually be able to perform that training and that deployment. It's not cheating. It's just because your business use case is unique doesn't mean the code that has to perform the machine learning bits has to be unique, which I know is a big surprise to a lot of people at first. But Jumpstart is sort of catalyzes the beginning for a lot of people without having to really like come to this realization themselves first.
So Nick, one interesting thing is that you mentioned that again, SageMaker is kind of this middle layer of abstraction. It's for your trained machine learning users in your company. But let's say that I'm a startup, and my the thing about my startup is that it's not really approaching AI and ML from an AML per se. It is approaching it from a data analytics perspective, right? What I have on staff are experts in database administration, data analytics, data scientists. Now, I think we could spend a lot of time sitting here and debating where that line gets drawn, but at the end of the day, what I have are people who are in these different databases working with that data directly. How do I enable those kinds of people to take advantage of all the developments and the features that we've announced?
Exactly. There are a lot of scenarios in which you bring other parts of your infrastructure to the heaviest part of your infrastructure. Data has weight. Think of it like gravity exists, and along with that weight, not just in cost and familiarity with the tools, is also the ease in which it'll be accessed, right? And so whether it's data analysts, whether it's database engineers, data engineers, right? They may not be proficient or have a desire or have a business use case for having to spin up an entire proprietary AI and machine learning stack. In many instances, let's say you're working with user reviews and you have that as text fields in your database. If all you really want is sentiment to be able to query and understand as another additional column, a lot of these launches here bring that machine learning insight directly to the database, to where your data lives. And largely the way it's accessed is not unique to the way that you're accessing the raw data already. So remove the need and cut out the need to have an end-to-end training process, nonetheless custom inference infrastructure. We see in Redshift ML and earlier in the year, Aurora ML, Athena ML, and now Amazon Neptune ML, even for graph databases, this understanding that great data has gravity and weight, bring not just the compute, but the actual insights that we know customers are looking for straight to the database, and they can query them directly through SQL and other common querying techniques. And this isn't just for databases either. This trend continues. There are other organizations and teams of organizations that are consuming data maybe one step above the database level, where they're consuming dashboards or they're consuming reports or auto-generated report tooling. But they still want access to say, hey, here's a set of time series data. It'd be really nifty if I could see what at a glance, any anomalies in this data, right? That's a very human sort of query or question. And separate from the implementation of how that occurs, what if we could just get the answer from such a query? And that's what we see in Amazon QuickSight ML Insights and Amazon QuickSight Q. It is pointedly in QuickSight Q, the ability to ask questions in plain language, and in QuickSight ML Insights, it is the ability to derive machine learning insights directly from a dashboard rather than having to go further upstream to the data source or further into a custom pipeline to perform inference on data that exists there, which again, is really just empowering more people at the organization to generate novel machine learning insights that everyone at the business wants to be able to use.
Yeah, the point about ML Insights is really spot on because this is expanding. If you think about a typical organization, you usually have your data scientists, your analysts, and it may be one or the other that kind of goes and configures your dashboards to track your KPIs and your OKRs and whatever, right? But really, the consumers of those services are some of your BI analysts, your marketing managers, teams all across the business need this to kind of inform how they're building their feedback loops. And uh, at that level, you can imagine that there's these speed bumps that get in the way when somebody looks at that information and asks a second order question. And then what that does is it kicks off this development process where now the team that built the original set of dashboards and visualizations has to go and answer this new question in some bespoke way. And that's really the question that you're describing right there. What if we could automate that? What if we could um, uh, take some of those questions and take some of the natural language that you use to ask them and just build it right in?
Yeah, and I would say even the real landscape here is even more complex, not in a difficult way, but in a full in developing a full understanding, right? Like Rob, you and I wear many hats. We sling code, but at the end of the day, we also write reports based on data sets that are probably sitting in Excel documents or spreadsheets or databases, right? Like we consume data from multiple parts of our organization, and there are lots of times where just because I could author code to perform manual ETL and then outputting graphs, like at the end of the day, I may want to use something for that use case of generating a report quickly and easily. And so it's not just about identifying individuals at the company, it's about really pairing a tool to the right job. And there are many people at a company with many different job titles that may have that particular job, and it may not be their full-time job, but having the tool that eases that pain is something that I'm excited about. Like I will use this personally for some of my own work, and it's not because I don't want to write code otherwise. It's just because it's simply a lot faster and easier.
Yeah, and I know how particular you are about your tools, so that's a good litmus test if you're going to use it.
Exactly. And, speaking of tools, we have even more here because when you use a tool, it's often to solve a problem. Maybe it makes your life easier. You could call that the challenges or friction a problem. But this was the last point that Swami gave in terms of, enabling companies to innovate with AI ML. First of which is Amazon Kendra. This again was announced last year, I believe, but it is intelligent enterprise search with those natural language queries, similar to what we saw there in QuickSight Q. Your search or your ability to find data is only as is bottlenecked entirely by the number of sources and the breadth of sources you can actually index to be retrievable. And so with Kendra, very excited to see 40 plus new connectors. So if you're trying to search in plain language for data that exists throughout your organization, whether that be tickets from Jira or commits in GitLab or messages in Slack. Those are now amongst the many 40 other or 40 plus connectors for Kendra to more effectively surface insights into the data of your organization. But we also have two very pointed additional solutions here. So first is Amazon Lookout for Metrics. Very interesting name. It, when we break down metrics, essentially what I want you to think is any arbitrary time series data. So it is something that you sample it is a data or a property that you sample at some frequency. And what Amazon Lookout for Metrics enables you to do is pass in a feed of that data, or you submit that to the service, and it will tell you through a response whether there is an anomaly that's being detected. Now, notice there I didn't describe anything about you having to train a model, you having to select what or describe the data in any way. Really, this is again just a lookout for changes in your data, and all of the levels of normalcy are determined automatically through the service itself. So you can pass in everything from business metrics to telemetry from your applications if you want. But again, if you're looking for some sort of alerting or automated alert surfacing system for things like utility usage, if you collect that data, if you're looking at um, spend or energy usage, or ad impressions, you expect a certain amount. You don't have to be able to designate that. Look out for metrics could surface if there's an anomaly in that for you automatically. So we typically think about time series anomaly detection in a much more esoteric or technical use case, for solving for like system metrics or surfacing of alarms for say memory or CPU utilization, right? But this here again, a service built for more general customer use cases, without having to dive into more of the hairy bits of machine learning at all.
Yeah, another great example of just how we're bringing the advantages and the capabilities of machine learning and AI to all sorts of different people who wear different hats in different industries. I think the Kendra point was really great because the power of a system like Kendra is with its integrations, all the different the sources of data that it can integrate with. Same thing with kind of look out for metrics, the fact that you can kind of get it training and detecting anomalies without any sort of hands-on configuration, fiddling, or need to understand the model underneath. This is just really great stuff to see, and it's all happening across the board.
Yeah, exactly. And I know we have about 20 minutes left. There's so much to cover in the infrastructure keynote, but I promise I'll close out after this one. The last machine learning launch that I wanted to cover here from this week was Amazon Health Lake in preview. Now, with all of what I've described, whether you perform machine learning already or you train those and deploy those systems or not, you're probably surmising that, hey, this could be challenging, this could be difficult. Now, throw on a lot of the additional complexities of trying to achieve very specific requirements for compliance for data governance, privacy, encryption, and so on that are so prevalent in the health tech space or the healthcare space, and it becomes very obvious that even if you have all the tools at your disposal, it's difficult to sort of put all of this together and confidently deploy a system that will, on the first try, hopefully achieve compliance. And so that's exactly what Amazon Health Lake does. It is a pointed solution to customers that exist in the healthcare space that says, okay, here are the types of levels of compliance that you want to achieve. Here are best practices that are baked in through connectors and integrations for these various data storing and transporting and analysis and visualization, access patterns that or functions that exist in the healthcare space. Again, all with an eye on doing so in a compliant and easy to use manner for customers that are in healthcare. And again, this is, if you are a budding healthcare company and you want to be able to stand up a service that is essentially an end-to-end, I don't want to say like a data CMS, but a CMS that is performant with all of the fundamental AWS building blocks that you can extend and build your own custom tech on top of, with all of the rock bottom foundational pricing of a lot of the AWS services. HealthLake is the only direction I'd really point you to. Your time is one of your most valuable resources as a startup, and HealthLake is quite literally that pointed solution to all of your data management needs there.
Yeah, and another thing I want to point out about these kinds of services, HealthLake's very interesting because it's a service that is aligned with an industry vertical, and you can kind of see this in some of our other services, with like Game Lift that are aligned with games and entertainment. Some of our media encoding services to do with multimedia workloads. And this, as an aside, I really want to give a shout out to our solution architecture team because this is one of the components that makes AWS unique, in my opinion. Because when you use one of these services, you're not just using a product or a set of products that are purpose built to support your industry. You also have support from professionals who used to work in that industry and have themselves been a guiding hand in the development of these services, right? And so this is, in my opinion, an excellent example of how we kind of bring all these disparate components together to be truly customer obsessed, to truly really take a look at the industry and the customer that we're serving and make sure that we're building a best in class service or product.
I couldn't have said it better myself. I would not be surprised if a solution like this was a realization among specialist SAs in the health tech space that had said, hey, here are recurring challenges, here are recurring implementations and patterns we've seen. How can we make this even easier for customers to deploy? And we have solutions that are not necessarily standalone services, that are reference architectures that you can spin up with IAC, either a CDK stack or a CloudFormation stack or a CDK code to modify. But this is really the first class citizen, right? It's a standalone service that manages this exact problem for this exact vertical, that ties it all together in a buttoned up way. So love to see that. I wholly expect us to see more services in this sort of dichotomy, with this sort of shape, right? That solve these pointed problems for different industry verticals. And we even saw that with some of the AI services that Andy mentioned in his keynote for manufacturing, namely Monotron, Panorama, Lookout for Vision, and so on, right? So solving these foundational problems for pointed industry use cases, and sort of having the best of both worlds with an out of the box turnkey solution. Love to see it. But we only have about a little under 20 minutes left. How about we jump over to what we saw today in the infrastructure keynote?
Yeah, sounds good. So this morning we had Peter DeSantis, SVP of Global Infrastructure, take us through his ever popular infrastructure talk. This is similar to previous years, but it also focused on some of our most recent announcements. In particular, we're going to take you through a quick recap of how he talked about the Graviton 2 processor. But to give you a quick outline of what he discussed, he kind of quoted Werner, our CTO, that everything fails. And from that idea, really comes this you can see the seeds of how and why we built our regions using the availability zone architecture. And we had Jeff Barr on the show earlier this morning to tell us, he remembers back when he launched or he wrote the launch blogs for EC2, that availability zones weren't always around. And this is one of those things where, now that we have them, you look at them and you're like, of course, that makes total sense. Why wouldn't we how would we do it any other way, right? But that attitude it doesn't actually capture the full scope of what it was like before this thing was invented or this problem was solved. In fact, before that, we didn't even know what the optimal distance between these availability zones should be. In fact, that distance was actually worked out using a number of inputs. For example, one of those inputs is round trip network latency on dedicated fiber in order to enable synchronous replication between your database write master and your read replicas, right? Think about how that's so specific. And what we know now is, actually, if you start to run these synchronous replication workloads, and you have latencies of more than a millisecond, you start to see some weird things prop up. You start to see, a violation of various ACID guarantees, linear readability, that kind of thing. And these databases may not have, just weren't necessarily designed to operate like that, right? So we have what Peter calls the Goldilocks zone, which is really availability zones that are close enough by to have round trip latency of between 100 microseconds and 1 millisecond. Now, that's extremely fast, but what that gives us is a bit of wiggle room in terms of how far apart to set these data centers. Why is that important? Well, it turns out that when you operate services for both Amazon.com, the retail site, and for customers all over the world across every industry, availability is kind of important. And when you have so many critical workloads, we just talked about healthcare, for example, we have various government workloads, we have transportation, we have pharmaceuticals, we have so many critical workloads that just simply cannot afford to fail, right? And when we talk about that, we have to really take a look at the things that can cause failures on the 10-year horizon. Actually, I think to quote Peter directly, what is the 100-year flood that happens, for a given region? And it turns out that it's different per region, right? The hazards in the Midwest, might be hurricane or tornadoes. Down in the Florida or Texas, it might be hurricanes. And so on and so forth in different continents. Right. I mean, I know you have a really a favorite story here about that maybe you want to tell about insects that have somehow evolved to what, digest polycarbonate.
It almost sounds like an urban legend in a sense, and I really wish I could point to the canonical source for it. But we think of natural disasters and forces of nature like big scary tornadoes, hurricanes, floods. But it can be as mundane as like let's say just the power goes out on one side of the street, but not the other. It can also be as exotic as you're laying fiber in another part of the world that you've never traversed before. You're abiding by all of the standards and all of the best in breed equipment that you've been using, and all of a sudden you start in your preliminary test to see some packet loss. And when you really replace all of the physical equipment and you try to track this down to the root, you quite literally get to the point where like I'm gonna grab this cable and follow it and see what I'm going to end up with on the other side here. And the AWS team did exactly this when we were expanding into certain regions and found that there was actually bite marks and fraying of cables that were otherwise rated for extreme quality and durability. And when you really get to the bottom of it, it turns out that in this very particular part of the world, there just happened to be both a lack of people that had tried to lay this type of cable before, and also the prevalence of a particular insect that could eat and use its particular acid to degrade the cable, right? So absolutely wild, and something that you could not have forecasted, especially if it had never happened before. But also, you learn the lesson and then you improve it and you solve it and it doesn't happen again. But there is no compression algorithm for that experience, right? The first flood that I'm sure ever knocked out two data centers said, wow, okay, well, this is another threat vector that we need to defend against and harden ourselves against in all of our global infrastructure. And so, these years of experience are not lost on us. In fact, we embrace it and we use this to harden our services and our infrastructure so that you don't have to think about that in the shared responsibility model. We're happy to inform you and make sure that you deeply understand that availability isn't magic. It's not fairy dust you just sprinkle on it. Even just talking about how to deliver power in a redundant way was very exciting. And again, sometimes that comes down to just deeply understanding embedded software, right? Like if you can't even understand your failure cases, how are you ever going to harden against them? And Rob, maybe you want to go into a little bit of the things like blast radius, complexity, and sort of how Peter and AWS have tried to resolve some of those unknown unknowns all the way down to the data center level.
Yeah, I mean, Peter's. This is one of the reasons why Peter's talk is always one of my favorites from reInvent, is because you really get the sense that he's taking you through years of experience. He's inviting you to put on the hard hat and roll up your sleeves and be an infrastructure operator for just half an hour with him, right? The things that make him lose sleep. You mentioned just delivering electricity to a data center. This is something we take for granted because power here in the United States. We're very fortunate that the power grid is pretty stable in general, and I hope it's stable wherever you are. By the way, otherwise, how would you be watching this? But the reality is, when you start to talk about delivering power reliably and securely with something like 7 nines of availability. By the way, 7 nines of availability is 3 seconds of outage per year. So to give you a sense of just how reliable these data centers need to be, then even something as seemingly trivial as power delivery become incredible challenges because of the complexity of the underlying equipment. He took us really deep, right? He took us, for example, into the connection between the switch and the uninterruptible power supply, and how in both cases you have both pieces of hardware, and you open it up, and wow, okay, well, one is clearly more simple than the other. Is that actually the case? Well, it turns out that when you add in all the complexity of the firmware that runs those things, the complexity just shoots through the roof. And even if you go and try and disable all the features that you don't care about when these manufacturers ship these firmware updates, you still end up with something that is much more complex than what you actually need. And it's Peter's job, it's his team's job to kind of understand what the compound effect of connecting these systems end to end actually is, right? And this is what leads our global infrastructure team to go and invest in innovations like our self-designed micro battery packs for slotting into racks. This is going to dramatically reduce the time it takes to kind of isolate a failed unit, replace it, and then have no downtime, and then to keep going. But going back to the availability zones thing, all this is to say that we do this for all of our regions, all of our availability zones. And then what? Why are these availability zones so important? I talked about kind of synchronous replication earlier, and really, what this does, I mean, if we just keep popping up the stack, what we end up with is we now, customers that run on AWS have fewer trade-offs to make, right? Customers, when they operate on AWS in a region that has multiple availabilities, and by the way, that's every region. Um, what we are actually doing is we are equipping them to not have to make a painful trade-off between synchronous replication and high availability. That's extremely powerful. I don't have time to really unpack that, but it is a very, very powerful enabler for all sorts of different architectures and applications. We got to keep moving because we have so much more to cover. But so next up, we have some of the AWS Silicon, and we've been working with Annapurna Labs since 2014 to deliver some truly incredible custom silicon. Nick, you want to take us through the outline here?
Yeah, and before I get into any of the particular launches, the story I want you to keep in the back of your head is the much like delivering custom rack batteries and simplifying a UPS. When you have this deep vertical integration and a end-to-end understanding and purpose-built handoff, you eliminate a lot of the inefficiencies that occur in what are totally normal and reasonable abstractions, right? When you're building a service or a product that's used by a large number or a wide variety of different customers, sometimes these things can exist, like simply converting power from AC to DC consistently, right? But the story here with the Graviton 2 is AWS having deep expertise and knowledge in the workloads that are operating in AWS's cloud. And with the partnership in tandem with Annapurna Labs, we took to the mission of saying, if we had to design a processor or a custom silicon to optimize the workloads that are running on our infrastructure, again, we deeply understand it, we manage it end to end, what would that look like? And that's what we see with the Graviton 2 chip. But that's not actually the first. That's actually not the first exciting launch here. And it would be the Nitro system, right? The Nitro system was this first launch in where we removed the need to have hypervisor overhead on underlying infrastructure, and instead saying, okay, we can have the Nitro system layer that can then delegate and give you sort of all of the performance out of a given piece of hardware. Now, an additional add-on to that we saw at reInvent last year was Nitro Enclaves, a deeply sorry, I just tapped the mic. Deep isolation of these virtualized environments and virtualized infrastructure, such that you can have these sliced and diced horizontal scale out workloads that you can still ensure this like absolute security. And I can't even remotely do it justice. Like I think it was Colin McCarthy who announced it last year and dove deeper on that. But the Nitro system in isolation, yeah, there were quite a few people that understood deeply what that meant. But I think this year is where the pieces came together with the launch of the Graviton 2 chip, this extremely cost-effective, optimal price performant ARM-based chip that we were able to roll out in, I believe it was the C-class instances this year, with gains of up to 40% from the C5 to the C6N instances. And again, to put that into perspective, you flip a switch, and as long as your applications are built or are compiled to run on ARM, which a lot of them already are, even if they may not have been in the past, you can access 40% price savings by just flipping a switch. And that is you want to talk about low hanging fruit in terms of being able to save money. I can't even imagine another way of being able to do so without making any other trade-offs or questions around what that means for your application. It is literally a switch that you flip. That also enabled, and Rob, you can take this one, was a very exciting launch on the first night of reInvent, which was new Mac OS instances, which I know not many of us saw coming or expected, but were made possible, to my understanding, by the advancements in the Nitro system.
Yeah, it was really cool to see some of the screenshots of our chassis in our data centers. There was a screenshot from that Peter showed where he kind of pulled out one of the trays in this chassis and showed that it was just a regular Mac Mini, and the Thunderbolt port had been connected to the Nitro 4 chip, and we were kind of remotely controlling the Mac Mini. I like to imagine, for the Mac Mini, it's a little bit like being in the Matrix or something. Um, but it was really, really cool, right? Because this is something, like you said, none of us could have seen this coming. We know customers have been asking for this for a really long time, and I know the team has been working on it for a really long time, thinking about it, talking to customers, listening, and making sure that the moment was right and the feature set was right. And it seems like the Nitro 4 system, with its latest series of improvements, have made that possible and feasible. One other thing I wanted to say before we move on from custom chips here is going back to the Graviton 2 chip for a moment. One thing I especially liked about the keynote is the fact that we talked a little bit about what it is exactly that makes this CPU so performant and so cost effective and so energy efficient. And you kind of tipped us off here earlier when you mentioned that it's an ARM chip, right? Part of the reason why it's so much faster, cheaper, better is because we've basically made an architectural shift from x86 to ARM. Now, one of the things here is that we've actually, by moving from x86 to ARM, people also refer to these as the complex instruction set CISC and RISC, and ARM is a reduced instruction set architecture. And part of what this means is that it has a different approach toward simultaneous multi-threading. On Intel CPUs, this is known as hyper-threading, right? And this is where a single core will be able to process multiple threads as opposed to a single core processing a single thread. And Peter skillfully showed how this has a number of knock-on consequences, right? You end up with cores that are now optimized to kind of keep the core fed, and that takes up a lot of transistors. And then you have power management. You basically have, if you visualize the die on the chip, you have a whole bunch of different pieces that are kind of peripheral to the actual workload of like the floating point processor and the adder and the registers and the caches, right? The core things that you actually want the cores to didn't, pun not intended, but when you move in general, and this is why the name actually carries this is the reduced instruction set, and especially with the ARM CPUs, what you see is that by having that CPU and each core in that CPU focus on a single thread, a lot of these peripheral capabilities of the chip are unnecessary. And so the entire surface area of the chip, of the die, is freed up to kind of either expand your cache or to add higher core density. And that is one of the many factors that's driving this, right? Of course, the architecture itself is constantly being improved. But at the end of the day, if we zoom out, what is this doing? This is allowing one of the big things. I mean, so performance. That's an apples to apples gain. You said this is low hanging fruit. I think it's picked and washed fruit, frankly. But beyond just delivering those performance gains, it's much more energy efficient, and that helps us. That segues us into the next point that we want to make, which is some of the progress that we've been making as part of the climate pledge. Now, I just want to kind of zoom out. Big picture, take a look at what we're doing, right? We have all sorts of framework optimizations that you heard Nick talk about with Sagemaker that make your workloads faster, that make them more efficient, that make them parallelizable. Those workloads themselves can now run on instances that are themselves more powerful. Those instances are run within data centers that are being built with newer, better, and more carbon efficient processes and materials. Basically, we are investing in energy efficiency and reducing emissions across the entire stack. And there's so much going on here. Nick, you want to take us through this?
Yeah, we've got only a minute left, but you teed it up really well. We hinted before that the Graviton 2 is not just more performant, but it is extremely energy efficient. It's in fact, in Peter's own words, the most efficient chip, energy efficient chip we've ever used on our infrastructure before. And that's it's extremely exciting. There are three main ways you can achieve the climate pledge that Amazon has set forth, which is again net zero carbon by 2040, 10 years ahead of the Paris Agreement. And again, 31 other companies have joined, and Amazon has personally put forth $2 billion in funding to invest in low carbon projects. And outside of internal investments that we make to improve our products, which we'll get to in just a second, a lot of that $2 billion goes to like revitalization of water and natural resources in areas which we may host data centers in. Examples of this being like watershed restoration projects in Brazil and Cape Town. Or preventing of invasive species. I feel like this is the only time I've ever talked about invasive species twice in a single talk that are not related to one another in Cape Town, for example, right? But then on our side, internally, what can we control? We can try, the greenest energy is the energy we don't use, right? It's like the easiest machine learning pipelines are the ones that you never operate. We achieved this through deep vertical integration and optimizations on the data center side. So we saw that in UPSs, right? Up to 35% energy conversion loss can be prevented by not having to convert AC and DC power back and forth in using common commodity power infrastructure. Additionally, the Graviton 2 processors 2 to 3.5 times the power per watt than any other AWS processor, right? 2 to 3.5 times as efficient. So immensely valuable. Again, anyone who upgrades from the C5 to C6 G instances can access that. And even further, cloud instances themselves or cloud data centers themselves are 88% more efficient than otherwise enterprise data centers for a variety of reasons that largely involve right sizing and very, very accurate forecasting and capacity planning. Next up, we have renewable energy. Again, AWS is the largest investor and purchaser of green and renewable energy. And I believe this year alone brought us to 6.5 gigawatts of renewable energy globally, which also in 2020 was the largest amount of renewable energy expansion of any individual corporation. So no stopping of expansion with regards to data centers, and having the growth of renewable energy purchasing sort of go hand in hand with that is always great to see in my book. And then lastly is the need to reduce indirect emissions. Again, these being things that you don't necessarily think about when you think about the carbon that goes into maybe a server or chips. It's oftentimes the concrete and some of the materials and processes that construct the data center itself that you may never get itemized on a receipt, but you want to deeply think about. And so, we've been thinking about things.
Or yeah, or the cows that feed your workers, right?
Yeah, exactly. And these are all things that need to be considered when you're trying to truly deliver on a promise of net zero carbon, right? It's not just about absolving yourself of personal responsibility or guilt. It's about actually thinking deeply about these complicated end-to-end problems and the impact and footprint that you have as an organization. So excited to see reductions across the board. Hopefully I can be up here again next year talking about more of the same and even deeper levels of improvement there. But unfortunately, we're out of time. Rob, we had just an hour here on the weekly recap. We got through everything that we saw in the AIML keynote from Swami, and more timely, the Today infrastructure keynote from Peter DeSantis. Again, 2 of the 5 keynotes we'll see here throughout reInvent. But this concludes week 2. We have some more content coming up right after this, so we're not quite done just yet. But that is all the time that Rob and I have, unfortunately. I'm sure we could go all day if we really wanted to. But Rob, thanks again for being the partner in crime here for the English Weekly Recap. Coming up next on the schedule, let me check very quickly. We have an industry live session for power and utilities. Quite fitting with what we concluded with right here. So stick around, everyone. We will be right back, and we'll see you soon.